Okay, so welcome to another flipped video. And in class today, we're going to be discussing how to solve a simple linear equation. So we've been talking in class how with an equation, both sides have to be equal. So think of that balance. The left side has to equal the right side. That's what makes it equal. That's what makes an equation true. So we're going to learn how to solve an equation in the form of ax plus b equals c. A, b, and c are just numbers, and x is an unknown. But keep in mind, we know x is not always the way we represent an unknown, but it's a very common way. You can have different variables, m, n, r, t. So just keep in mind, x is an unknown or a variable. So in addition to this video, you need to read pages 144 through 146, and I believe it's just at the top of page 146 because that's also where homework problems begin. So again, today, solving linear equations. And then we are going to be reading pages 144 through 146. So let's get started. We're first just going to look at some examples here. It says solve the equation for the given variable, then check your solution. So this says 6x plus 4 equals 22. So what does that mean? 6 times some number plus 4 must equal 22. So we could kind of do a trial and error thing with that until we figure out 6 times 12 plus 4 is 22. And maybe some of you already have that. But let's learn how to solve these simple linear equations. So the first thing we want to do, whatever the variable is that we're solving for in this case, what's the variable? You're right, it's x. We want to isolate that variable. We want to get it all by itself. So we want to get the x by himself. I want to get rid of everything else that is not connected to that variable x. So what's the first thing I'm going to do? I look at either side of the equation. Can either side be simplified? I mean, can I combine any terms? 6x and 4 and 22? No, we can't. So now we can go ahead and start isolating that x. So the very first thing we're going to do is subtract 4 from both sides. And remember, if I do it on the left side of the equation, I must do it on the right side. Everything always has to stay balanced. Well, 4 minus 4 is 0, so I just bring down whatever's left. I have 6x, it's still there. 22 minus 4 is 18, very good. So I have 6 times x equals 18. So how do I get rid of that 6? How do I make that 6 just become an x, a 1x? Well, what divided by 6 is 1? 6. So because it's 6 times 6, I'm going to undo that. I'm going to divide both sides by 6. 6 divided by 6 is 1. So I can just write that as x equals. We know that the coefficient of that is 1. 1 times x is still just x. 1 times anything doesn't change that number whatsoever. And then 18 divided by 6 is 3. So I'm saying, okay, x is 3. What is the value of x that makes this equation true? 3. But remember, it said check your solution. So let's go over here to the side and just quickly check our solution. So how can we do that? How can I ensure that 3 is the solution? Just plug it in. So a lot of times you'll see me make a little check mark to show that I'm checking my work. And then I'll write out the problem again. So now, what can I replace x with? Yes, 3. So whatever this is, I want it to equal 22. So I just want to continue to simplify my left side. Now, again, going back to what we learned earlier this year and what you'll need forever, order of operations. So we first have multiplication, 6 times 3 plus 4. And again, we're checking to see, does this equal 22? 18 plus 4 is 22. So yes, left side equals right side. Good, we got the answer right. And you know you got it right before you ever even have to ask or check your work and say, hey, did I get this right? You're going to know already if you check your solution. Keep in mind, another thing that we've discussed in class, every single one of these equations is equivalent because the value of x that makes this true and makes each equation true is 3. okay? Just like over here, each step here is equivalent to the previous step. So 6x plus 4 equals 22 is equal to 6x equals 18. X equals 3 is equal to 6x equals 18, which is equal to 6x plus 4 equals 22. So just keep in mind, every single step is equivalent to the previous one. We haven't changed the equation, we're just writing it in a different way, similar to fractions. 1/2 and 2/4 are the same thing, the same fraction, just written in a different way. Okay, let's go on to another one. Now this one's a little bit different because we have a fraction with our variable. 1/3 n minus 9 equals 2. But we're going to follow the same setup. We look at either side of the equation. Can we simplify either side? Can I combine any like terms? No and no. This 9 doesn't have an n with it, so I can't combine them. So now that I know that, again, I want to start to isolate the unknown, the variable. In this case, my variable isn't an x, it is an n. So I want to get this guy all by himself. So what am I going to do? Well, should I multiply by 3 first? No, don't do that. Always get rid of, I call them stragglers, things that aren't directly hanging on to that variable. So I'm subtracting 9. I want this to be 0. I'm trying to get everything moved away from this variable. So what should I do to both sides? Instead of subtracting 9, I'm going to do what to make it 0? Yes, I'm going to add 9. Now can I just add 9 to the left side? No, because it's going to be all off balance. We've got to keep the left and right side equal. So left side equal sign it, I add 9, which means I have to do the exact same to the right side. So negative 9 plus 9 is what? 0. Good, that's what we wanted. So we are left with 1/3 n equals 11. I'm kind of running out of room here. So where did I get my 11? The 2 plus 9. So again, you just bring everything down. This 1/3 n was still left over. Negative 9 plus 9 was 0. I don't have to write n plus 0. So now what? I've got 1/3 times n equals 11. So 1/3 times something is 11. Or another way to think about it is what divided by 3 is 11. And again, maybe some of you guys have that answer. But let's work with an equation like this, especially with a fraction. So how many of you are saying divide by 1/3? Okay, I hear that a lot. But let's get in that practice of, instead of dividing by fractions, it's the exact same thing as what? If I'm dividing by 1/3, it's the exact same thing as multiplying by the reciprocal. Very good. So what's the reciprocal of 1/3? 3 over 1, or just 3. So I'm going to multiply this side by 3 and multiply this side by 3. Now why does that work? Remember, any number multiplied by its reciprocal is 1. So 3 times 1/3, I'm left with n, or 1n, same thing, equals 11 times 3, 33. Okay, I really hope it's right. But how can I check to make sure 100% this is correct? Well, we check our solution. So we go back to our original equation. I'm going to kind of try to block this off here. So here's my check. I have 1/3 times something minus 9 equals 2. All right. Well, I can now replace n with what? I said 33 is what makes this equation true. So 1/3 times 33 minus 9 should equal 2. So let's check. So again, order of operations, we're going to multiply first. 1/3 times 33, which is the same thing as 33 divided by 3. So that's 11 minus 9 equals 2. 2 equals 2. Oh goody, we got another one right. So there's 2 examples. Let me go over 2 more, and then I'm going to give you 2 to try for your homework tonight. Okay, yet another one. What's my variable this time? Back to good old x. So again, we're solving for the unknown. We have one unknown and it's x. We wanted to figure out what value of x is going to make this equation true. So if I take negative 3 and I multiply it by x, and then I add 5 times that same x, minus 4, it should come out to be 50. Again, we could try plugging in numbers all day, but if we solve the equation, it's going to go a lot quicker. So first look, can I simplify either the left or the right side of the equation? You guessed it, yes, we can, because we have like terms. We have a negative 3x and a positive 5x. So what is negative 3x plus 5x? 2x. And then I just bring down everything else, because nothing else has changed. So keep in mind, these two equations are equivalent, just written in a different way. This is a more condensed, more simplified version. So now, I can go ahead and solve the equation. So what do I want to do first? I have 2 times something minus 4 should equal 50. Again, get rid of the stragglers, things that aren't directly attached to x, because that's going to be the last thing. It's clinging on. It's the last thing that we can pull off of that variable. So I have minus 4. So how do I make this 0? How am I going to cancel that out? You got it. I'm going to add 4 to both sides. Well, negative 4 plus 4, 0. Good. We wanted that gone. But we still have this 2x. So I just bring down this 2x equals 50 plus 4 is 54. So 2x equals 54. Well, what does 2x mean? 2x means 2 times x. Or when I multiply x by 2, I get 54. So how do I undo multiplication? Yes, divide. So 2 times x, I need to divide by 2. Why am I dividing by 2? Because 2 divided by 2 is what leaves me with 1. We don't want 0, because if we have 0x, do we have an x? No. Well, I divided left side by 2. What else do I have to do to make sure I'm solving this equation correctly? Yes, divide the right side by 2. Whatever you do to the left, you have to do to the right. So 2 divided by 2 is 1, so I'm left with x, which if you want to write a 1 in there, you can. Typically, you don't see it, though. 54 divided by 2 is 27. So my answer is x. I'm going to take out that 1. X equals 27. But if you like the 1 in front of the x to remind you that the coefficient is 1, that's okay. So x equals 27. So what do? Go back, plug in, and check your solution. And again, just kind of save on time. I'm not going to do that. But you will be doing it for your homework. But all you do, wherever you see an x, plug in 27, make sure left side comes out to equal 50. Again, every single step, this equation, this equation, this equation, and this equation are all equivalent. They all represent the exact same equation. Okay, last one. 15 minus 3 halves m equals 10. So what do? Left side versus right side. Can I simplify the left side? Can I simplify the right side? No. But I want to isolate that variable. In this case, my variable is m. Again, variable, the unknown. So I'm trying to get this guy all by himself. So what can I do? 15 minus 3 halves m equals 10. Well, is 15 positive or negative? Yes, it's positive. So I have a positive 15. So how do I get rid of it? How do I make it 0? I subtract 15. If I do to the left side, I have to go over my balance here, go over my equal sign, and subtract another 15. 15 minus 15 is 0. What am I left with? Negative 3 halves m equals negative 5. Where did negative 5 come from? 10 minus 15. Okay. So again, this equation equals this equation. So now I have negative 3 halves m equals negative 5, or negative 3 halves times m. Well, how do I get rid of that negative 3 halves? Divide by negative 3 halves. Okay, what's dividing, what's the same thing as dividing by a fraction? Multiplying by its reciprocal. Very good. So, reciprocal of negative 3 halves is negative 2/3. So I take the left side and I multiply it by negative 2/3. Why does that work? Because any number multiplied by its reciprocal always is 1. Negative 2 times negative 3 is 6. Over 3 times 2 is 6. 6 divided by 6 is 1. So if I did that to the left side, I've got to do it to the right side. Okay. Well, that's 1, so I'm left with just m equals Negative 5 times negative 2/3. Don't get out your calculator. You can do this in your head. So remember, negative 5 as a fraction is the same thing as negative 5 over 1. And when we multiply fractions, we just multiply straight across. Negative 5 times negative 2 is negative 10. No, it's positive 10. Remember, negative times a negative is always a positive. So negative 5 times negative 2 is 10. 1 times 3 is 3. So 10/3. And you can leave your answer just like that. So let me come off to the side here. M equals 10/3. How would I check my solution, which you will have to do? You take that and plug it directly in for M to make sure that you got the equation correct. Okay, so for tonight, I'm going to give you 2 equations to practice on. So solve for the given variable. Those 2 equations are, I need to go back in and fill in some of my writing. Okay, some of it got erased, sorry about that. Okay, so you're going to solve each equation for the given variable. The first one you're going to do, negative 5 plus 3x equals 16. The second homework problem, 30 equals 3w plus 9. So they look similar to what I've given you, but maybe not exactly the same, but you're still going to use that exact same process. All right, good luck. I will see you tomorrow in class.